So welcome everybody. Thanks for joining. Even though I know it's already end of the year, sprint, and everyone's maybe busy with other projects. So we will today talk about how we can actually reduce cost with data-driven manufacturing from digital concept to results in weeks. My name is Danny Rybkowski. We are from the company Cybus. Cybus is a software vendor for the industrial enterprise market, serving with one main software, which is our connector, and it serves as a factory data hub for bigger digital transformation projects. I'm Danny Rybkowski. I'm leading the partner management team, so mainly working together with delivery and sales partners. And I brought my dear colleague with me, Anthony. Maybe you'll take a second as well to say hello.
Yeah, welcome everyone. So my name is Anthony, head of customer success, meaning our goal is to enable our customers and partners as fast as possible to be proficient in Connectware and implement use cases on their own. I live in Cologne, and I'm really looking forward to the content of this webinar. So let us dive into the agenda for today. Danny will lead you through a common challenge we all have. I will guide you through a customer example, and then Danny will talk to you about how to lower marginal cost with a factory data hub and to speed up scaling with collaboration. Then I will sum it up in the learnings from over 30 plus projects, and then the 20 minutes will already be over. So, Danny, handing over to you, why is scaling so difficult?
That's a good question. Maybe just before starting, one disclaimer. If you have questions, just please write them down in the chat if you have it right now, so we don't forget it at the end. So then we can start in our QA. All right. So why is scaling so different? What's the common challenge here? Before actually answering that question, I would like to actually ask a question to all who is here. So what is your most pressing challenge when digitizing your factories? We see a lot of different answers at our customers and when we're working with partners especially. And we just brought out 3 different ones, which we thought which are the most frequent ones. So please just take a second, make an answer. If you're not working in an own factory, maybe you can answer as well for your customers' factories, who are you responsible for, or who is or where you're working with that. So basically whatever you feel was the most fitting answer. And I'll give it another 5 seconds because we have already the first votes. Perfect. So there another vote incoming. All right, then I'll stop the vote, and there we go. So most answers are actually around collaboration between involved stakeholders and finding a fitting technology. It's actually, to be honest, the perfect start, I think, to our presentation. So without further ado, let's take a look into the next slide. So what's the biggest challenge we still see in most digital transformation projects? We see that we have most of those 4.0 initiatives who are there normally to reap benefits, they actually drive costs instead of reducing them. So all of these great use cases like digital twins or predictive maintenance or just energy management, whenever we want to implement them into a very complex shop floor and factory setup, which was what we see on the left by this nice logo collection, we found that in 60% of all the projects, it just takes too long to reap any benefits. And that's basically creates a lot of costs and a lot of slow projects. So I want to pause just for a second, take a look on what's data-driven manufacturing. Most of you already know. I just like very much this definition. It's adapting your production to the data generated from your production. So actually that means that we're listening to the production, and that requires transparency. So based on that we can actually see what's happening in our production based on live data, and we can adapt and react based on that. So how can this look like actually in a, let's say, an ideal scenario? If we have, for example, 30 factories, right, and we start by having some base industrial connectivity. So we lay all of this out. We have our systems and assets connected, and then we start with a first use case. Might be, for example, status monitoring, and one of our customers achieved a downtime decrease by 8% only by knowing what machines are currently running, what not, and whenever there's a problem, they could go there and already solve the problem. So, and that decreased that downtime there by 8%. Then next project could be there if you work with data, an energy management project, reducing costs up to 30%. We have a webinar on our 3 latest customer examples doing exactly that. And then another project might be is basically material waste. So reduction of material waste based on reclamation. So for that, you need as well data from your ERP, MES, and shop floor as well, and to see if everything is working in line and the quality is okay. With that, we can, of course, scale to further use cases. So with that data-driven manufacturing approach, what you want to have is really always look into production, what's working, what's not working. Based on that, execute some use cases and reap benefits. Yes. The question would be right now from me to you, Anthony, how does this actually look like in a real life example? Or is this all a little bit dreamland fairy?
It is and it isn't. Every customer is different. So what I brought with me today is a customer example from Krone. Krone is an agricultural machinery producer. They have 4 production sites in that division, about 6,000 employees. And they were facing 2 main challenges in terms of bottlenecks in delivery. They lacked a little bit of flexibility in production and traceability as well. So they had quite a unique opportunity as they were building a new production site in Ibbenbüren. That is what we call greenfield. So you can completely design an architecture from scratch, and with that, we can dive a little bit into their goal. So they took that opportunity and said, let's build a smart factory reference architecture for our data-driven production for all production sites. It should ideally be pliable for completely new and existing sites. It should be event-driven, it should be future-proof, and it should be scalable on 2 dimensions. So first of all, within the plant, you want to be able to reuse the data you have collected for a multitude of use cases. And then you want to take that learnings from the use cases and everything you've built in one plant and basically copy it as far as possible to other plants. That's scalability on 2 dimensions. So what was the solution? Krone really took advantage of the current research standard and the expertise of a well-established digitization expert here. So they were developing a reference architecture, which I will show you in a moment. And they were in parallel also developing the right organizational structure to support scaling the digital architecture they are building. And this really ended up in also the selection of the right technologies, which is where we come into play. So let's have a look at the architecture. The key takeaway here is I don't want to go into too much detail, but we have a decentral management component and a central management component. The decentral management component, the core component is Connectware as a factory data hub. So our goal is to collect, standardize, and pre-process data in every plant. So Connectware, what does that mean for scaling? Connectware is installed in every factory, and then also sending the data to a global broker on the central management plane. And the combination of these 2 brokers allows for fast scalability and to use a low-cost structure because of the reusability of the data. Um, and what's also really, really important in this example, and I want to highlight that here, is the collaboration. So what Krone did, and I mentioned it before, the right organizational structure is they set up a central data team, which was able to leverage the knowledge of every stakeholder involved. So they used the knowledge of the operational technology, the information technology, and closely involved business for the use case expansion. And that is something which is on top of technology really, really important for fastly scaling. Then Danny, could you perhaps skip to the next slide?
Yes, of course. Let me check. There we go.
Thank you very much. So let's continue with the benefits for the customer. So first of all, we have low maintenance cost for the data infrastructure that was built here. That means that a small team comprised of about 4 people is able to maintain the whole architecture while also implementing the use cases and driving the expansion. The second benefit is Connectware is already running on 2 sites, running 6+ active use cases, which a highlight is we all have automated order distribution in manufacturing machines and intralogistic AGVs here. And another highlight here is that these, or most of these use cases, were already independently implemented by the central data team itself. Which leads us to the most important benefit here, which is time. So usually these kind of projects take about more than 2 years. And after 8 months, we are finished with the aspect of enabling the customer to build use cases on their own. And that is quite an achievement here. And I can't stress the point enough, because time in that sense is really money. Because there's a lot of parties involved supporting, from consulting, from software vendors. And the faster you get to the point where you are able to implement on your own, the higher the probability of the whole project becomes. And in this case, a time saving of more than 1 year easily leads up to 7-figure saving. And yeah, with that, that raises a question on how a data hub is able to lower marginal cost and further drive faster scalability. And I want to have a little bit of a deep dive here into the technology, Danny, and the correlation between these 2 points. Perhaps you could elaborate that a little bit.
Yes, of course. Happy to do so. So if we take a look into the underlying technology there, how does it normally look like if we are approaching such a project, right? So on the top, we see different use cases starting in the middle with a traceability use case or status dashboards or energy management. And all of those use cases require data, right, from our shop floor assets and as well from our IT systems like an MES or modular MES services, which is the trend right now, an ERP, our AWS or Azure services. And so it's an interplay of those. And the classic integration was always to do point-to-point integrations, which creates, of course, high customization costs and long project cycles. Then basically the right now the go-to-market strategy for most bigger companies is to introduce a middleware layer. We call it Factory Data Hub of our connectware. What does it typically consist of? It's always some kind of connectivity. So we need to get or send the data to and from different systems. So we need to have protocol conversions capabilities. We need to pre-process the data as well. We need to be able to centralize the data and have a communication layer so that we can apply different communication patterns based for the use cases which we need. And then every use case requires other operations, another data flow, right? Data in other format. And that's something which we need to apply for in a standardized manner. And last but not least, it's always important that only the users who are allowed to have certain data will always as well get that data, and that we can handle security measures very easily out of the box. So by introducing that middleware, right, that factory data hub, what we have now is that for each of those use cases, we can reuse the same shared data infrastructure. We can reuse the data we have. We have standard processes for introducing new assets, for introducing new systems, for introducing new use cases, as well for changing parameters or doing changes in the existing setup. So we really have a standard layer, and which then for each use case is lowering our marginal costs because we are faster, so we have this time to value, and we have those costs actually for the whole stack, which we need, which are going down as well. So that's the principle behind like using a factory data hub in a digital transformation project. Now, the question is, especially when we talk about faster time to market and about the collaboration in teams, because well, we get a lot from many customers that it's actually difficult to drive people to change, and like how can we foster collaboration to be actually faster. So in that case, what we typically see is the classic OT and IT separation. Then we have the business sides, who are normally the subject matter experts, for example, on traceability or our quality use case. And typically, what we always have that our IT people have their very own tools. So talking about infrastructure as code here. So coming from the cloud technology here, which they're familiar with, which they use for scaling. And then our OT people and business people, so who know where the data is, where the assets are, and as well what data they need on the top side level. They are more familiar with very simple tools like Excel and general no-code UIs. Through the connect, what we can do is basically supply now the IT persons or the department or the team, how it was at Krone, for example. They can basically, based on the use case, let's say it's traceability, they can supply different templates. For example, they can supply a template into the catalog for machine connectivity, for example, to a KUKA robot or to a FANUC robot or to an AGV. And on the other page, they can supply a certain template for dashboarding, for example, based on Power BI or Grafana. And those templates then can be used on a no-code base by our business users and our OT people. And whenever they're using it, they are not directly using it and it's like valid for the whole setup, but they will rather send a pull request. So they create it and send a pull request to the responsible central team, and they will check it, merge it to the central repository, which basically our single source of truth for the whole smart factory setup and all our use cases. And from there, we can deploy it through a CI/CD pipeline into the factory. Or we can as well copy and paste this pattern and go for like this through the next production line or to the next plant even. And by this, we can see that we can actually foster collaboration closer because everyone is still his subject matter expert, but with standard processes. And we know whenever there's a problem, who we will call. And by that, we can be like very, very fast in terms of execution time for new use cases. And from here, I'd like to ask another question towards you, Anthony, basically based on the Krone project, but as well on other projects, what are learnings we see from those projects in terms of reducing costs in the data-driven manufacturing approach?
Yeah, of course. So what I would like to use here to show that is a little graph. On the x-axis, we have time. On the y-axis, we have profitability. So it's profitability over time. And there's two lines, one red one blue one. And the red one is what Danny described. If you go on a case-by-case basis, it's really, really difficult to achieve profitability because it's a whole new digitization project on itself. There's no synergies, there's no reusability. It's really difficult. So your main focus should be really on time to value. and which basically means all the advantages, or not advantages, all the highlights I brought with me with the Krone example is bring the right people to the table, give them an ambitious enough goal, set clear responsibilities, and foster collaboration on two dimensions, on the organizational dimension and through technology. So find the right technology, which is not only used by one user group, but ideally can be used by different user groups. Which then in turn, of course, lowers the marginal cost. I've said it already, reusability is key here. What you need to watch out for as well is look at the total cost of ownership of the technology you select, not only at the initial cost, but also on how complex will the solution get in the end, and how many people do you need to maintain operating that system, right? The last point is be selective about the first use cases. I mean, it depends on the industry, it depends on the production side, but ideally, the first use cases already have a return on investment. And Danny gave some good examples at the beginning of the webinar. If you have questions regarding that, you can always contact Danny or me. And with that, I'd only like to say in a nutshell, really in one or two sentences here. So successful cost reduction at scale requires shared data infrastructure, central data team on customer side with clear responsibilities that collaborates closely with all involved parties. It's not easy, so it's not only about one component, it's not only technology, it's not only organization. There's a lot of moving parts that need to come together to achieve real cost reduction. But that's it, and now we're open for questions. So let's have a look.
Okay, I'm not seeing any questions incoming, Anthony.
Me neither.
Same for you.
Then I'd say thank you very much for listening. We have a lot of other webinars and upcoming webinars. You can also have a look at our schedule for the fairs we are attending next. We would be happy to see you there. Danny, do you have any closing remarks?
Closing remarks, no. But in terms there are any questions being raised about what happened, for example, at this Krone project, you want more details or about examples of like certain projects, just ask straight up Anthony or me. We put out our LinkedIn there, so feel free to contact us directly. For those who don't know us yet, so besides the familiar faces I can see in the chat here. And from my side, yes, thanks for being here. Thanks for taking the time. It was a pleasure talking with you.